Picture this, it's 2024. A Category 4 hurricane named Helene slams into the Carolinas. Streets are ripped apart. Cars are swept away like toys. Families are evacuated in the middle of a torrential downpour. But the real shocker: that storm didn't just happen. It was cooked up by a precise, yet terrifying, scientific formula. It feels random, a chaotic act of nature. But the truth is, a hurricane is a colossal, meticulously engineered heat engine. It's Earth's violent way of balancing its own temperature. If you think of a hurricane as a monster, we are about to reveal its blueprint. We will show you its secret recipe for destruction. Most people see a hurricane and only think of disaster. But here's the mind-blowing scientific concept. Hurricanes are Earth's safety valve. The tropics soak up intense solar heat. That energy needs to be released and moved towards the poles. Without these massive storms, the equator would boil and the poles would freeze solid. To Earth, a hurricane is a necessary function. To us, it is a catastrophe. This entire process follows a rigid recipe of physics and climate. It needs 4 main ingredients. You can't make a viral video without a hook, and Earth can't make a monster storm without these 4 components. The first ingredient is warm ocean water, and a lot of it. The temperature needs to be at least 80 degrees Fahrenheit, about 26.5 degrees Celsius. But here's the critical detail: it's not just the surface. That warm layer has to be deep, at least 150 feet. Think of it like a car's fuel tank. A thin film of gas burns out instantly, but a full tank lets the engine run relentlessly. When this warm water evaporates, it carries immense potential energy. When that vapor condenses into clouds, the energy is released. It's like unlocking an invisible battery. More heat, deeper water, bigger battery, bigger storm. The second ingredient is moist and unstable air. The air near the warm ocean is saturated with water vapor. As it rises and cools, the vapor condenses, releasing heat. This heat makes the air mass lighter and causes it to rise even faster. This is a terrifying feedback loop, a self-amplifying system. Imagine a single popcorn kernel popping. That small burst of heat and pressure quickly triggers a chain reaction. Soon, the entire pot is crackling violently. That's exactly what is happening in the atmosphere. Once initiated, storm cells gather, feed each other, and grow into a colossal system. The third ingredient is the opposite of what you might expect: low wind shear. Wind shear is the change in wind speed and direction with height. If the shear is too strong, the nascent storm will be ripped apart before it can grow. To become a massive hurricane, the column of rising air must remain upright and stable. It must be like a gigantic chimney. High shear is like someone violently shaking a table where you're trying to build a 50-story Lego tower. It collapses every time. The weaker the wind shear, the taller and stronger the atmospheric chimney can grow. The final ingredient is something you experience every day, but rarely think about: the Coriolis effect. It is a direct result of Earth's rotation. It's this force that bends moving air masses. In the northern hemisphere, it deflects them to the right, creating the signature counter-clockwise spin. Without the Coriolis effect, you cannot have a hurricane. This is why hurricanes never form right on the equator. The rotational force there is simply too weak to create the necessary spin. Once all 4 conditions meet, the system drops in pressure. Air rushes in, gets bent by Coriolis, and the whole system begins to spin. From there, it evolves into a tropical depression, then a tropical storm, and finally, a massive hurricane. The internal structure of a mature hurricane is mind-boggling. At its center is the eye, a cylinder 20 to 40 miles wide. It is so eerily calm that sometimes the sun shines through. It's the moment of peace before the worst of the storm hits. Surrounding the eye is the eye wall, the storm's most intense region. Here, the most severe winds and rain occur, sometimes exceeding 1/5 mph in a Category 5. The sheer energy released by a mature storm is almost impossible to grasp. Get this: a single hurricane releases heat energy equivalent to 10,000 nuclear bombs every day. Over its lifespan, its energy output is greater than the total electricity production of the entire world combined. We use the Saffir-Simpson scale, which ranks storms from Category 1 to 5 based on wind speed. But this number can be dangerously misleading. Take Hurricane Sandy in 2012. When it hit New Jersey and New York, it was barely a Category 2. Yet it caused over $700 billion in damage. Why? Because the scale only tells part of the story. Sandy merged with another weather system, ballooning its diameter to nearly 4,000 miles. Its slow speed and massive size caused a catastrophic storm surge. That surge flooded the Manhattan subway system. The lesson is clear: a slow, weaker storm can be more devastating than a fast, moving Category 4. The real killer is often not the wind, but the water. One of the most terrifying phenomena is rapid intensification. This is when a hurricane jumps 2 to 3 categories in just one day. Imagine going to sleep with a mild tropical storm offshore, only to wake up to a Category 4 bearing down on your city. This is exactly what happened with Hurricane Michael in 2018. It exploded into a 255-mile monster just before hitting the Florida Panhandle. It left behind war zone like devastation. This rapid change has doubled in frequency over the last 400 years. It gives cities virtually no time to prepare, forcing last-minute evacuations and exponentially increasing the risk of loss of life. And now, a new variable has been thrown into Earth's recipe: climate change. Warmer oceans mean more fuel for hurricanes. North Atlantic Ocean temperatures hit a record high in 2023. This is raising fears of supercharged hurricane seasons. Research shows that for every 1°C increase in temperature, the amount of rain in a storm can increase by 10 to 15%. More fuel, more rapid intensification, and more water means more catastrophic flooding. What was once a rare event, a storm jumping from a Category 1 to a 5 overnight, is now becoming a chilling new normal. So, the hurricane is cooked up by a subtle dance between warm water, moist air, a gentle wind shear, and the Earth's majestic spin. When all these ingredients lock into place, they brew a storm capable of changing a region's economy and its coastline. Forecasting has dramatically improved. Our 3-day track predictions today are more accurate than the 1-day predictions of the 1970s. However, predicting that rapid intensification remains the greatest challenge. The fate of any storm hangs on countless atmospheric variables. As the ocean warms, that challenge only gets harder. Understanding this formula isn't just science, it's survival. It's knowing the blueprint of the beast, so we can hopefully, one day, stand a better chance against it. What's the most extreme weather you've ever experienced? Let us know in the comments below!